Hello guys, welcome back to Perspy Science. In our last video we introduced the work, energy and power. In this video we focus on work done by a single force, how to calculate it and when it is positive, negative or zero. Work done by a force, it is when a force moves an object in the direction of the force, or it is force multiplied by the distance moved in the direction of that force, which mathematically can be denoted as WF equal to F multiplied by delta X multiplied by cos theta, where F represents the force which is measured in newtons and delta X represents the displacement measured in meters, and theta, it is the angle between the force and the displacement, and the W, which represents the work, which is measured in joules. So before we continue, keep in mind that work is a scalar quantity, therefore it doesn't have a direction. Then we have what we call a positive work. What is a positive work? Positive work is the work done on an object to move it in the direction of the force. And again, we have what we call a negative work. A negative work is the work done by an opposing force. So, a positive work, it increases the kinetic energy, and a negative work, it decreases a kinetic energy. Keep that in mind, you might find it in your examination. So, let's look at a quick example. An athlete applies a constant force of 10 newtons to push a box to the left. The box displaces 5 meters to the left. A kinetic friction force of 40 newtons acts on the box to the right. Calculate the work done by each force acting on the box. But how do I approach this question perspicacious, because you only teach definitions? Oh, wait, let me take you there. First thing that you do, you have to collect your data. According to the statement, it is said that the athlete applies a constant force of 10 newtons, which means that is your force applied, and the box displays 5 meters, which means that's your change in x, and there is a kinetic force, which means that's your Fk equal to 40 newtons. From here, you have to draw your free body diagram representing the moving box, which we covered in our last video. First, you draw the dot representing the object. Then you draw the force which is always available, which is your weight or your Fg, and you know it is always going downward. Second, you draw your force applied going to the left. Then, is there a surface? Yes, you draw your normal force. Is the surface rough or not? Obvious, they gave us Fk, which means the surface is rough. You draw your Fk opposing the motion of an object. The object was going to the left, which means you draw your Fk going to the right. From here, each and every object must have an angle. But how do I do that perspicacious? You simply have to draw delta x going to the direction of the object. Since the object was going to the left, you have to draw delta x using dotted lines going to the left. Now we give every force its angle according to delta x. If we consider the Cartesian plane and use delta x as our starting point, which means at delta x it will be our 0 degrees. Then if we move from delta x to the normal force, we are moving 90 degrees according to Cartesian plane, since they are perpendicular. And again, if we continue and move to Fk, it will be 180 degrees, since Fk and delta x, they are arranged in a straight line. And again, if we continue from Fk to W, which is our weight, it will be 270 degrees. So that's how we give our forces angles. From there, we move to calculate the work done by each and every force. First, we will consider the work done by force apply, which will be equal to force apply multiplied by delta x multiplied by cos of a theta. And if we check, we are given force applied, so we plug in, and we are given delta x, we plug in, and we said our angle for force applied, it is 0 degrees. So if you press your calculator, this will give you 50 joules. Remember the units for work. Number 2, we calculate the work done by the normal force. So work done by normal force, it will be equal to normal force multiplied by change in x cos of theta. You plug in. But if you check, you are not given force normal. So you put it as it is. Delta x, it will be 5 cos of 90. According to trigonometry, a cos of 90, it is equal to 0. So anything multiplied by 0, it will give you 0, which means the work done by normal force, it is equal to 0 joules. Then we move, number 3, we calculate the work done by Fk. Work done by Fk, it is equal to Fk multiplied by change in x cos of theta. You plug in, you are given Fk as 14, delta x as 5, cos of 180 degrees. So if you punch into your calculator, this will give you negative 70 joules, which is your unit. Then we move to number 4, work done by weight or work done by mg. It will be equal to mg delta x cos of theta. What is the value of m? You are not given, you plug in your m. What is the value of g? It is 9,8. Then your change in x, you are given as 5 cos of 270. According to trigonometry, cos of 270, it is the same as cos of 90. It just gives you 0. So anything multiplied by 0, at the end it will give you a work of 0. You put your unit, joules. So let's check which force did a positive work, a negative work, and also a 0 work. If you can check work done by force applied, we got a value of 50 joules, meaning force applied did a positive work. Work done by normal force, we got 0 joules, meaning it falls under 0 work. So work done by Fk, we got negative 70 joules, meaning Fk, it did a negative work. And work done by Mg, we got 0 joules, which also fall under 0 work. So if you can check carefully here, the work done by normal force and the work done by weight, they are equal to 0. Meaning that the work done by perpendicular forces, they will be always equal to 0, because perpendicular give us 90, either way it can give us 270, and according to trigonometry, a cos of a 90 and a cos of a 270, it always gives us 0. So you might need to keep that in mind for your exam. Again, keep it in mind that a positive work, it increases the kinetic energy, and a negative work, it decreases the kinetic energy. So don't be confused. As I said earlier, work is a scalar quantity. So the negative sign doesn't mean a direction. It only means that energy, it is decreased. Thanks for watching Perspy Science. If this video helped you, please like and subscribe. So in the next video, we'll be doing the work energy theorem, which will connect the network to change in kinetic energy. See you in the next video.